Hey everybody. Hope you're doing well. So getting some comments on my last video, and I just had one just pop up while I was getting ready to do this. So I read through that one as well. So for those of you who haven't watched my video from yesterday on the AI frame problem and how I think it ties to the MBTI intuition, young intuition. Feel free to watch that, but I will I'll acknowledge that I, there were a few times where I sort of misspoke and I was like saying bomb when I meant battery or saying battery when I meant bomb. So sorry, I realized I was sort of butchering it as I was going along, but let me try to clarify some of that stuff and address some of the comments because I think they're interesting and are just food for thought. And this is the kind of stuff that I'm like totally into. So I appreciate the comments and the interaction because it gets me to sort of think about it a little bit more and sort of stay focused on it. And of course I close the tab that I had. So now I gotta go back. So bear with me here. All right. Um, okay. So a couple of comments. So one that just came in, which I thought was good, and I agree with everything that the commenter said, but it still sort of leaves open like, okay, but how? And just real quickly, the for those of you who might not have seen the first video, I'm talking about this thing called the frame problem, and I invite you to just sort of read the wiki page on it, or there's a good description of it on some page with Stanford. If you Google frame problem, it's one of the first things that comes up, the Stanford Encyclopedia of Philosophy or something like that. But at the heart of it, it's basically this problem with computation and in computer science, um, and specifically in AI now. But it's this the idea is if you have a series of formal statements or computer code, if this then that, if this then that, that kind of stuff. What happens if some entity like a robot or something actually takes action on the world and it changes the validity of that statement? So in other words, your actions have consequences, right? If I pick up the cup and move it over here, now the first frame of, or the first sort of statement of the world, that the cup was to my right, is now no longer true. Now the cup is to my left, simply by my action, right? And so by taking action on the world, you're sort of changing the state of the world, and therefore sort of changing the validity of certain you know um, statements about it. Um, okay. And that causes all kinds of computational problems that we intuitively just sort of understand without it causing, wreaking havoc in our world. Um, and so, in the example that I give is the famous example from Dan Dennett about, you program a robot to go into a room where its battery is located, and if the battery is damaged, it's going to hurt the robot. And there's a bomb next to the battery, and the battery's on a wagon, so that the robot goes in, tries to pull the wagon to bring the battery with it outside of the room and away, presumably away from the bomb. But lo and behold, the bomb is also on the wagon. And so when the robot pulls the wagon out of the room, the bomb still explodes and along with the battery. Okay. So then you have to redesign the robot to say, okay, I want you to take into account the consequences of your actions. What is going to change given your actions, right? So then the robot goes in and starts contemplating all of the potential things that could change given its action of pulling the wagon. And there's a bunch of stuff that's irrelevant, and there's a bunch of stuff that would be relevant. For example, something that would be relevant is I pull the wagon and the bomb is on the wagon, so the bomb's going to come with me. That would be an important thing to acknowledge and pay attention to. But there's a million of other things that aren't important, right? And just from a pure computational, if everything is just programmed using simple computation, binary computation, that is somewhat of an intractable problem because if the robot has to take into account all of the consequences of its action, it's going to sit there and just think of every, possible thing that could or could not happen. And then boom, the bomb goes off because it, is sort of stuck in this infinite loop of calculating all the possible consequences. So then you've got to design the robot to say, okay, well, we only want you to pay attention to the stuff that's relevant, right? Don't worry about the stuff that's irrelevant. Just pay attention to the stuff that's relevant. Um, so then that also causes another computational problem of trying to figure out, okay, well, what's relevant and what's not relevant, right? And then, of course, the bomb goes off as it's trying to figure out what's relevant and what's not relevant. Now you compare that to simple human behavior, and instead of a human's battery being on a wagon, let's just say a puppy is on the wagon, and the human wants to save the puppy. But same scenario, the bomb's also on the wagon. Now, a human just intuitively knows somehow that, if I pull the wagon, the bomb's going to come along with it. So I either need to take the bomb off the wagon and pull the wagon, or take the baby off the wagon and run out of the room. But either way, we sort of just using common sense know that that there's a pretty easy solution to this problem that for whatever reason a robot that's based purely on computation can't figure out. Okay, that's pretty much the essence of the frame problem. And whenever I would teach this, it would, in like cognitive psych classes and stuff, um, it was kind of surprisingly difficult for people to understand because we're so good at figuring out take the bomb off the wagon or take the baby off the wagon, one of the two solutions. It's so much just sort of ingrained in our intuitive understanding of the world that it's almost hard to think about a a robot programmed that has some sort of knowledge about the world that can't solve it, right? um but lo and behold, it really is this very complicated um problem in the AI field and just computation in general. Now, okay, so let's get to some of the comments here. um So this is a comment from one of the new comments from Money 9948, and you can see it on my previous video because I'm going to kind of paraphrase through it. Um, so, assuming the robot comes equipped with some form of object detection, saying blah 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 blah. Okay, we'll assume that. Also, with some additional alignment classifier. Okay, now this is an important point. With some additional alignment classifier, so some sort of rules of the game, rules of survival, avoid danger, save valuable object. Okay, and some basic a priori maximize distance between bad and good object. Um, okay, simple rules, and I'm going to get to that in a second, but good so far. The loss function to be, let's set the loss function to be maximize distance between good and bad. So let's maximize the distance between the bomb and the battery. And I think the thought experiment, the Dennett thought experiment, sort of presupposes that, right? I mean, the robot is trying to pull the battery out of the room using the wagon. So it is trying to distance the battery from the bomb. So I think we're good there already. Well, where each action or change in the environment is evaluated through that lens. Okay. Um, okay. And so so the robot's sort of just focusing on, let's separate the battery from the bomb, or maximize the distance between the two. Okay. Input space is highly dimensional, where there is a ton of features in the environment which may or may not be relevant. Does the color of the wagon matter? Does the race of the baby matter? What is the temperature of the room? Okay, so yeah, so there are an infinite number of things that are irrelevant, and then there's maybe a subset of things that are relevant. And let's just say we focus on the subset of things that just have to do with what the robot is paying attention to, trying to separate or maximize distance between the battery and the bomb. Um, Even there, it still has to go through a pretty exhaustive, if not, I mean, maybe not an infinite list of possibilities, but a very, very long one. If it's just focusing on, what's going to happen if I move this wagon, Dennett uses the examples of, well, it's going to turn the wheels and it's going to have such and such force and blah, 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 blah. A lot of stuff that, even though it's sort of, you're still sort of selectively attending to the task at hand and not things like, the colors of the wall going to change. And I realize I was sort of using this as examples in my other video, but let's just not worry about like sort of the goofy examples. Is the air temperature going to change? Are the colors of the walls going to change? That kind of stuff. Even just focusing on, the task at hand, there's still sort of this very, very exhaustive long list of things that it would have to compute and go through. Now, maybe it's not as long as when you're taking into account all the other stuff, the silly stuff, but it's still a lot. And so even there, the robot has to figure out what's relevant and irrelevant, just given the task at hand, what it's paying attention to. And it has to have some sort of knowledge about the world, which I'm going to get into in a second, about the fact that, if something else is on the wagon and you pull the wagon, that something else is going to come along with it, right? And I think that's sort of the crux of the problem, is sort of figuring that out and knowing that that's relevant. But in the broader context of the thought experiment, there's also silly stuff that it has to take into account. Like, how does it know to just selectively attend to the problem at hand and ignore all this silly stuff, ignore all the other stuff that, isn't directly part of the problem at hand, right? I mean, that is the essence of the frame problem, right? How do you frame the problem or how do you frame the goal to just the relevant information, just the stuff I'm supposed to pay attention to? And so it's difficult to sort of presuppose that, okay, well, the robot's going to know what's important. Well, how do we know that? How do we know that the robot knows what's important? Okay. Computationally, that seems to be impossible. Um, from just a pure computation, if you sort of ignore the common sense part of it, just pure computation, like knowing, okay, this stuff is relevant and this stuff is not relevant. It really has to go through each sort of combination and permutation of the effect of all of its actions. Um, okay, and so in a way, I think this comment is sort of, and I could be reading it wrong, and I get that, the frame problem is very hard, and it's very hard to articulate everything you're thinking about in 3 paragraphs in a comment. So I get that. And I don't want to be sort of assuming things that are wrong, but I think the commenter is also just sort of assuming, well, you just come up with a program that makes it focus on what's relevant. And that is sort of the epistemological problem, right? And they call it the law of common sense of inertia, right? That most things in the world are not going to change. If I move the cup over here, then pretty much everything else in the world is going to stay the same. Now the cup's hot, so maybe the temperature of this, external hard drive I have over here might get a little warmer. Or maybe this side of the room is, this side of the table is going to get a little warmer. But that's kind of irrelevant stuff. But everything else in the room is going to stay the same. And that's what people in the area, refer to as the common sense law of inertia. That, unless you directly have some action on an object, you're really not going to change everything else about the world, or everything else about the world is probably going to stay the same. Okay. Um, but that's sort of why Dennett uses this example of having the bomb on the wagon along with the battery, because your action is affecting the wagon, not necessarily the bomb or the battery. The direct action is directly affecting the wagon. And the robot has to have enough knowledge about the world to know that pulling the wagon is not only going to move the battery, but also going to move the bomb, right? Okay. So we can illuminate. So I'm going to move on. We can illuminate features that do not impact define loss function, which does not require a priori knowledge. So without going into much detail, as a computational heuristic, things that are highly correlated with each other could be treated as a single entity. Okay. So I guess highly correlated might mean close together in distance in this example, maybe. Or instead of keeping, so let's just focus on things that are close together. Okay, you could program that in. That will save some computational costs. So don't worry about the walls, because the walls aren't really correlated with this battery on the wagon with the bomb. The bomb is somehow quote unquote correlated because it's close to it, I guess. Um, but you could change. I mean, you could do the annoying thing that and change the facts of the thought experiment, and imagine that instead of them both being on a wagon, that they're attached by a bungee cord or something, and so the bomb's all the way across the room, but it's somehow tied to the battery with a bungee cord. So when you move the battery, the bungee cord sort of snaps, and you sort of bring the bomb along with it, right? So it doesn't necessarily have to be a wagon. It doesn't necessarily have to be on the wagon, but you could program something in to say, if things are connected by, some sort of object, okay, just pay attention to those things. I get that. And that certainly is something you can focus on. Um, but that's sort of how people are trying to solve the frame problem in AI, is to sort of build these kind of priori assumptions or heuristics, um, that like try to survive. It's sort of like the 3 fundamental rules of robotics, right? Don't kill the humans. Um, Sort of build in these sort of a priori laws, and I think that's sort of the interesting thing, right? You you could read some papers on what people think the a priori programming sort of rules or axioms are. Um, and the list just keeps getting longer and longer, but at least you're not paying attention to things like, do the walls change, that kind of stuff. Um, so it could be things like, just pay attention to things that are connected in some way or close to each other, um, in proximity. And that is something that people in the field sort of are trying to figure out, like, what those a priori rules are or what they should be. Um, and then also, the other way of sort of tackling this problem, of course, is just having robots or AI systems learn through experience, right? So interaction with the world. Um, so, one argument could be that, the reason that a person can solve this wagon problem so quickly and intuitively is because we have experience in the world with wagons, right? If I tell you that both the bomb and the battery are on the wagon, you just sort of intuitively, it's a weird word to use, but you instinctively or quickly know that if you pull the wagon and both things are on the wagon, you're going to bring both things with you. Now, some would argue that's just because you've got experience in the world with what wagons are, right? So imagine an alien comes down and it has no idea, somehow they skipped over the wagon part of technology. Um, and it has no idea what a wagon is, but it knows everything else that a human does. Are they going to be able to figure out just as quickly as a human does, that, oh, if I pull this thing, the bomb's going to come with it? Or, are they somehow able to solve that problem, but have never had any experience with a wagon? So, interesting thought experiment. I don't know. We'll see when the aliens come. We'll give them a test. Um, so, okay. So let's keep going here. So this shaves computational costs. Okay, finding some a priori rules of things to focus on. Also, there are some things that change in the environment ultimately do not impact the defined objective function, such that we can ignore it, shave computational resources. Yeah, I mean, I yeah. So I mean, we're ignoring it. I think what the commenter is saying, and maybe I'm misreading it, is that there are a bunch of things that we could ignore if we just have these sort of a priori rules. And again, I think that's what the AI programmers are trying to figure out, is what are the a priori rules. But how do we know what to ignore? Again, how do we frame the problem in a way where we're ignoring the irrelevant information? And that is really the crux of the issue. Um, and so I think it's hard to just say, well, just program it to ignore all the irrelevant stuff. Okay, great. But that's what we're trying to do. How do we figure out how to ignore the irrelevant stuff? And then that goes back to, okay, well, let's just have a list of sort of a priori rules of what makes something important and what makes something not important. Um, and of course, the people in the field sort of argue about what those rules should be, or I don't know if they argue about it, but they're all trying to figure out what those rules should be. Um, but somehow humans, we figured it out, and I think it's sort of a combination of two things. I think there's, you know, um, sort of instinctive knowledge, fixed action patterns or whatever you want to call them, things that we inherit, avoid danger, avoid big scary things that are bigger than us, louder than us, that kind of thing. Um, and that we've learned through evolution, and our brains are just sort of fixed to that. And then if you want to dig into the Jungian area, there's archetypes, right? We probably have some sort of knowledge about the world in our collective unconscious that we were born with, that we're tapping into somehow, that, in general, mothers are good. In general, warriors on our side are going to protect us. Warriors on somebody else's side are going to be a threat to us. In general, older, males with long gray beards and pointy hats are going to have knowledge about the world. Just those sort of archetypes that we've somehow developed through um, cultural experience, I guess. Who knows? But the ribbon of consciousness out there in the universe is telling us this. Um, one way or another, we've built in these a priori rules that allow us to know what's relevant and to know things about the world, even though we haven't directly experienced it. Um, And then there's also just direct experience, right? You have experience with wagons. You know what the effect of your action is going to be, given your experience and general world knowledge about wagons. Um, and, you could argue that's an SI component. I'd argue that somehow that experience is laid down in sort of an SI episodic memory, but it also sort of consolidates itself into more of an NI general knowledge about the world. That you don't necessarily have to think about a specific experience you had with a wagon to solve this problem of the puppy dog being in the wagon with the mom. You don't have to think about, that one time when you were pulling a wagon along when you were a kid. You have this sort of generalized knowledge about wagons, or things on wheels, that, some of it could be sort of innate, some of it could be, just sort of general experience, and it sort of gets lopped together into more than just your experience, but a generalized knowledge about the world. And I think both of those are going on. So you've got to have some sort of knowledge, you've got to have some sort of experience, and to solve these sort of quote unquote common sense problems, because you can't just rely on pure if this that computational um, processes, because you're going to run out of time. You're not going to just quickly and instinctively do it. But that's the big question. That's the big question that neuroscientists are trying to figure out. And AI researchers are trying to figure out, is how exactly do we do that? And again, I mean, if you guys have the answer, great. Go sign a non-disclosure agreement with Google and go work for Google and explain to them how all this works, and you'll make a lot of money, and probably win a few prizes. So okay, so I think I've addressed that comment, but I mean it's a very well thought out comment, and I'm not trying to argue with it or anything. I just want to make sure that we're sort of talking about, or that sort of the essence of the problem is acknowledged, that you can't just sort of assume, like, okay, well, just program it in a way where it only pays attention to the important stuff. Well, that is the question. How do you do that? Right. And again, people are thinking, you sort of build a sort of experiential knowledge about the world, and maybe some a priori rules about, don't hurt people, try not to get hurt yourself. Things that are connected to each other in time and space probably have some sort of connection or probably going to be affected by one another if you take action, that kind of thing. But it's tough. I mean, it's tough. How do you figure out all those a priori rules? Okay. What else here? So our friend Eric, or talking with famous people, I think had a comment here about yeah. So this was a response to one of my responses. So how do we know what to ... I'm going to hazard a guess here. Is it introverted intuition? Thesis seems to be, though explicitly stated as such, not explicitly stated as such, perhaps, that AI can do better NE than NI. I agree with this. Okay. So the argument that I was making in the previous video was that NI is sort of exploring the problem space, okay? Trying to figure out it's sort of the first step in the Dennett thought experiment of, figuring out what the effects of your actions are going to be. Sort of it's the what if function. What if I move this cup, or pick up this cup and move my arm and then put the cup over here? What is the new state of the world going to be, right? And I could do that without actually picking up the cup and moving it. I could just sort of, using NE, figure out what the new state of the world is going to be. And again, I see this as more of an NE thing than an SE thing, because it's a verbalizable state of the world. It's not just, it's in the physical world, but it's how you're computing it in sort of a verbalizable, metaphysical kind of way. I describe it as being to the right of me in this state, and then I would describe it as being to the left of me in the future state, right? If I took such and such action. And I see that as the NE problem space, figuring out how sort of the propositional nature of the world after taking an action. How do you describe the world after taking an action? And, it starts off cup to the right, it ends up cup to the left. Okay. So that's the NE stuff. But it could also sort of take into account, all the other stuff that could happen. Like, what's your reaction going to be if I move this cup over here? How is the world going to take that? Are people going to have a problem with me moving the cup? Or am I going to somehow, have too many things over on this side of the table that now the table is going to flip over because it can't bear the weight of everything over here? I don't really have to think about that kind of stuff, but it is this kind of stuff that NE might, if you turn on your NE, it could explore all that kind of stuff. Is the table going to break if I move this cup over? Is the table going to change colors? I don't know. Maybe if it, the color is somehow reacts to the heat, maybe, I don't know. Is so-and-so going to have is a viewer going to have a reaction in one way or the other if the cup is to my right versus the cup is to my left? Does that matter to them? All this sort of problem space stuff, NE can sort of unpack, right? And explore all the what ifs. But your NI, I would argue, is focusing on what's relevant, and if my goal is to just move this over here, whether or not a viewer on YouTube cares is not very relevant to me, in this context. But it could be relevant to me in another context. I don't know. You can imagine a scenario where it is. But the NI is going to sort of keep the NE in check and focus on what's relevant. And that's sort of the third step of the Dennett robot problem, right? So the second step is the NE, figure out all the effects of your actions and how it's going to change the world. And then the third step is, but only focus on the relevant stuff, right? And that's the hard part. That's the frame problem. How do you focus on the relevant stuff versus the irrelevant stuff? And again, I see that as more of an NI thing. I could be wrong, but to me, NI seems to be about relevance and sort of meaning and focusing on meaningful results as opposed to things that don't really mean anything or really have any real meaning. And so it's sort of building up the context. What do you pay attention to? What do you not pay attention to? NE is also dealing with context, but it's more about the situational context, where here are the different scenarios that could play out. Here are the different situations. Where NI is more about what are we focusing on? What context do we want to put a frame around and focus on? So in that respect, I don't know if AI is better at the NE or NI stuff. I think it's got a problem with both. Because if you think of NE as being the second stage of the Dennett problem of just trying to figure out all of the possible ramifications of your actions, I think that's computationally intractable just by itself, not even focusing on the relevant stuff, just focusing on or just having it compute every little possible thing. Now, it could probably do it. It just, if you have enough computational power and enough time, I guess it could probably do it if it's got enough knowledge about the world, or it can at least compute everything that it's able to compute or figure out. So I guess in that sense, it sort of has it, quote unquote, solved or is able to do it. But I still think that it's a problem in the sense that it's just not pragmatic. It throws a wrench into the system. It causes a problem with what you're trying to accomplish using AI, right? And so in that sense, we're no better off with the NE stuff or the NI stuff. So the NE stuff, again, is stage 2, figuring out the problem space. NI stuff certainly is a problem, and certainly I don't think even AI could do it at this point. Now, again, they're trying to figure out what are the a priori rules that allow you to frame the problem and figure out what's relevant versus what's not relevant, trying to learn through experience, things like that. And but of course, easier said than done, right? And I think they've sort of figured out like that's eventually what we need to do, but figuring out how to do it seems pretty hard. So that's my thought. I mean, I guess in some sense they've got the NI stuff sort of figured out, or at least it's computationally doable, but just not practical, given what we're trying to get AI to do. And that's the NE stuff, and then the NI stuff. Yeah, they're working on it, but I honestly couldn't tell you how quick they or how close they are to solving it. There is some scuttlebutt about this process called Q star, which I admittedly don't know a whole lot of the details, but back, maybe 6 months ago, almost to a year ago, there was a bunch of, people saying that OpenAI behind closed doors and somehow figured out general intelligence because it's figured out this Q star problem or this Q star way of approaching the problem space. Um, I'm not going to get into it because I really don't know it well enough to do it any justice. But if you're really interested in this stuff, look up Q star in artificial intelligence, and it's basically trying to navigate a problem space and figuring out whether the steps it's taking um, sort of gets it from its initial state to its goal state using this quote unquote Q star method. But again, I don't know the computation behind it, or, you know, can't really do it justice. Okay, so those are a few thoughts. Again, I'd welcome any comments. I'm really not trying to like argue with anybody or, you know, things like that. I'm just trying to clarify, really on my end, how I'm thinking about this stuff. And you know, and I appreciate the back and forth. So, all right. So thanks again, and see you guys soon.